Hello everyone. Today we are going to talk about magnetic declination. This has been very important and interesting topic for sea navigators. Sea navigation has a very long and interesting history. And one of the important things that has ever happened in the history of sea navigation was discovery of magnetic compass and its use to find directions and doing navigation. So historically, uh, when people first got to know about the magnetic compass and its use, they started using it to find the directions on the earth and to navigate through sea. But slowly they realized that the magnetic needle they are using is not always pointing towards the true north direction, and they realized that there is a variation, that it does point in some direction which is different than the true north direction, but this variation, this difference varies with place to place, and they have to figure out what is this difference with change in place. So this will explain the concept of magnetic declination. So let us try to understand the magnetic declination and the kind of problems that navigators might have faced. So let us think this ball as earth, and what we have done, we have put two axes uh, through its, you can say, center. Let us say this one as the geographic axis, and let us assume that there is another axis at some angle, and let us say this is magnetic axis. So what we see, that the two axes, the magnetic axis and geographic axis, are at some angle. So what happens, that when somebody suspends a magnetic needle freely at any place on earth, let us say there is this place, and at this place, let us say the magnetic needle is pointing towards this direction. So this is the direction uh, towards which magnetic needle, that is towards the magnetic axis, it's pointing. But the true north at this place is this, uh, is this. So there is an angle between these. So the magnetic needle is pointing in this direction, but it's not telling you the true north, the north geographic. So to know the north geographic at this place, we need to know what is this angle, and this angle is actually the magnetic declination at this place. So it is the angle that this needle, magnetic needle, will this is the angle between the true north and the, you can say, magnetic, you can say, south, or the needle in which is it's pointing. So this is magnetic declination at this place. Now what happens, uh, so to know the true north, one has to know this angle, but this angle is not constant. As you move to another different place on earth, suppose you are, let us say, now at another place, what happens at this place is that, say, this is your needle pointing towards the, you can say, magnetic axis, but your true north is this. So what has happened, as compared to this, the angle has here decreased and it's different and reduced. So unless you know what is this angle, you may not get the true north, because your needle will point towards magnetic axis, but true north is at some angle to this. Now if you move to another different place, let us say here on earth, so what happens, your needle points in this direction, and interestingly your magnetic axis as well as your geographic axis at this particular position overlaps, and and the angle of declination becomes 0. So your magnetic needle is here actually pointing towards the true north direction, that is towards the geographical north, because geographical north as well as the magnetic south are here kind of pointing in the same direction. So with change in place over the earth, the magnetic declination varies, and one needs to know this variation to navigate and to find out the true north, or true, you can say, directions, geographical directions at that particular place.